Broadcasting from Studio 202 at the Springett Technology Center in Navasota, Texas. It's NOV Live. Now, here's your host, Michael Gaines.
Thanks for joining us this morning on NOV Live. I'm not Michael Gaines, I'm Lydia Brantley, substituting in as he's away. Today we're talking with the people behind the products, specifically composite pressure vessels. If you don't know what composite pressure vessels are, don't worry, neither do I. We have an expert to teach us a little bit more. But before we get started, I'd like to kick it over to a familiar face, our social media specialist, Shelby Dumaine, to talk about how you can get involved in today's episode. Shelby?
Hey, Lydia. You know, I gotta say, nothing against Michael. We love having him host, but it's really fun to kind of get a new face, a new voice in here. So I'm really excited to have you on the show today.
Thanks for having me.
And I wanted to give a quick note to our audience watching. If you want to get involved with the show at any point today, you can comment whether you're on Facebook, LinkedIn, or YouTube. As you can see, I got my screens up here, so I'm in those comment sections throughout the entire show. And we will be doing a live audience Q&A at the end of the episode. So go ahead and get your questions in. Whenever you think of them, go ahead and type them there. And we're going to get to as many of your questions as we can before we have to end the show. And if you ever wanted to watch any past episodes, I also, I got to plug them. I got to mention you can do so on NOV.com/live. So I'll have that on the screen, but it's NOV.com/live. There you can see any of our past episodes of both this show as well as our morning show, Inside Out with Asad Mahana. And if you have a question on those shows, we still want to get your questions answered. So you can actually email us at socialmedia@nov.com, and we will get you in touch with any of our experts, any of our guests, to make sure that your questions are still getting answered. But like I said, if you want to get involved on today's show live while we're on air, just go ahead and comment them, and that's how we'll be able to get all of your questions. And those are all the different ways, I list off of how you can ask your questions. But now it's time for the part of the show where I ask you my question. It's time for Rig Geek Post of the Week.
Rig Geek's Post of the Week.
All right, and as Lydia mentioned, we're talking composite pressure vessels today, and so our Rig Geek is on that theme, and I did, I love to test our Rig Geek. Sometimes I like to ask a little bit of a more technical, tricky question, and I think that's one today, or it could just be me. It could be technical just for me reading it. Maybe for our Rig Geeks, it might be easy for y'all, so I'm interested to see what everyone says, but we're going to have the Rig Geek question up on the screen, but today we're asking you, what percentage weight savings can be typically expected when switching from conventional metallic pressure vessels to composite pressure vessels? Now, if you think you know the answer already, go ahead and comment it, or maybe throughout the show, if you hear more information and you think you have a good guess, and you think you might know what percentage weight savings can be expected, comment it then, and then at the end of the episode, after we do all of the questions, then we are going to reveal the answer. So stick around and see if you are our Rig Geeks got that answer right. So that's it for me, and I'll see you at the end of the show for that live Q&A. Again, go ahead and get your comments. But for now, I will shoot it back over to you, Lydia.
Great. So today we have Jim Roe, Senior Engineering Manager for Fiberglass Systems in Plymouth, UK. We're excited to talk to Jim. Thanks, Jim, for being here.
Hi, Lydia. Thank you very much for having us.
Well, so let's rewind a little bit. We've said the word composite several times already in this episode, and we have yet to explain exactly what that is. Can you tell us what is a composite? What is a composite pressure vessel?
So Easiest way to describe a composite material is it is a material which consists of two or more substrates. Typically for fiberglass composites, we have a resin matrix system which is reinforced by a fiberglass strand. That glass can be substituted with other reinforcements such as aramid or carbon fiber, but that is the general makeup of it. It is two or more substrate materials which form a engineered material at the end of the process.
Got it. So when people say fiberglass, they're just referring to a type of composite.
Very often, yes.
Got it. And then a composite pressure vessel. Tell me more about that.
So taking that first snippet of combination of materials in order to form an engineered material, we basically do that in order to replace existing pressure vessels or pressure containment systems. Those items are typically found in the open market for a number of different uses, things like fire extinguishers or water filtration systems. Obviously, scale is relative, so in our case, we're doing rather large pressure vessels with typical capacities ranging from sort of 500 liters and up.
Interesting. I never would have made the fire extinguisher comparison, but that's really helpful. So what we're going to show on the screen is just some examples of what people are using today, so you can explain to us what we're looking at.
Yeah, sure. So typically the applications we're looking to put composite pressure vessels into is for the oil and gas, marine type of sectors, where water processing skids and equipment are widely used as part of the oil processing aspects of what we do in NOV. Some of the pictures online are showing typical layouts of what you might find in a metallic variant. So steel structures, steel tanks, and then we sort of switch over and we can bring in the very unique side of what composites have to offer. So we've got two large composite pressure vessels on the skid there, which had been switched out for metallic items or switched out from metallic items. And they offered some significant benefits over the metallic versions. Two of those major considerations being weight and corrosion.
So when you talk about these skids that we're looking at, what specific applications are you discussing? Is this on the production side? Is this in drilling? Where do we see these CPVs?
They very much fall into all the categories and have a very diverse range of uses. Primarily, we utilize composite pressure vessels in very saline environments. So water injection systems used on rigs very often utilize a number of pre-filter stages. We can accommodate an awful lot of those filtration pressure retaining capacities with composite variants to what is ordinarily a steel vessel.
So often, I guess we're seeing it in a lot of offshore environments, but maybe when we talk saltwater disposal, et cetera, on land, we might see it there?
Very possibly, yes. The great aspect of composites or FRP as a pressure vessel material is it is completely unsusceptible to saline corrosion and has fairly decent considerations for chemical corrosions as well, which are some of the things which cause engineers and skid builders the biggest headaches.
No, that's so when we talk about the benefits of a composite pressure vessel versus conventional metallics, I feel like you've alluded to some of them. So the fact that it doesn't corrode, obviously point number one. Shelby mentioned weight savings in her Rig Geek question, so I figure that's point number two. But what are the other big benefits that we talk about when it comes to this?
The major benefit in utilizing composites is the fact that we can engineer the material to do exactly what we need it to do in terms of performance criteria. We engineer the makeup of the material, the layup of each layer upon the next, and all of that has relativity to the direction in which the reinforcement is applied to the structure. That versatility which we can bring through design is something which in metallics, you just don't have the same sort of range of flexibility.
Does it take a long time to build these composite pressure vessels?
No more so than what you would see for a metallic variant. The processes these days are very well established, and we are also very lucky that we have at minimum 4 different processes we can use or apply simultaneously in order to create a pressure vessel or various components of that particular item.
Great. Well, I like what you said of, I can tailor this to my requirements. It can meet my needs because it's not just the layout of the vessel or the skid, but it's the actual material of the vessel that we're using that we can customize probably isn't the right word, but that we can match to meet our requirements.
Yeah, customizing is actually a very nice word because it does illustrate very nicely what you can do with that material, and it can be customized from structure to structure. Obviously, the less customization, the more standardization you can bring to the forefront, the better off we are in terms of pricing capabilities and manufacturing consistency. But having that avenue of customization in order to provide unique, bespoke solutions for customers, as well as various different sectors within NOV, gives us a lot of power and increases the diversity within the company quite significantly.
Right. It gives you such a broad scope in terms of what you can do. So that's
Yes.
that's a lot on composites. Pressure being the second word in this item name. I figured that has a little bit more to do with the operating requirements. So where do we see, what are the operating requirements of composite pressure vessels? What stress do they go under?
So operating conditions can vary quite significantly, but in the realms where we are typically seeing composite pressure vessels used in most applications for things like coarse filtration, ultrafiltration, most often somewhere between 1 and 20 bar. The higher end of those typically functioning around sort of 16 to 18 bar is the area where most composite pressure vessels are these days focused. There is a much greater realm in terms of pressure for processing equipment such as reverse osmosis filtration, where we've also utilized composite pressure vessels, but pressures in those cases can far exceed 50 or 60 bar, and we have to date delivered vessels which were capable of doing just upward of 78, 79 bar.
Wow.
With 6 times safety factors on them. So you're talking at a vessel which had a burst capacity in excess of 300 or 400 bar, which is an awful lot of pressure in anything.
So this is something that you want contained within something that's safe and secure, clearly.
Absolutely. Yeah, being that the oil and gas market is one of the sort of leading bodies for safety across the globe, they set some pretty high standards, and in order to meet those, you have to be very sure about what it is you're pushing out, your facilities. And composite materials, not necessarily as well understood as what they could be or should be at this stage, but they have an awful lot of strength and benefit to bring to the table. As we mentioned, 2 of those major headliners being the weight and the corrosion aspects, which typically can cause asset owners and maintenance teams significant issues throughout the life of their assets.
So you mentioned kind of things being misunderstood or not well understood. Is that just because steel or metallics are so pervasive?
There's a lot of data behind metallics. The nature of the material so composite materials are based along a material property set which is anisotropic, so the strengths are completely different in different axes, whereas metallics are isotropic. Strength is universal in any direction, and that's where that tailored factor and the customization really comes into play. So we can maximize the strength potential in any direction we need it to be performing at its highest, and minimize the strength where we don't necessarily need it in order to reduce overall material usage during manufacture.
Are there any areas that have adopted composite pressure vessels widely? Like where are they already in use right now?
So composite pressure vessels are quite widely used, especially in the water processing industries. Reverse osmosis being a big player in that. Water processing skids with reverse osmosis type vessels on them most often have anything from 200 to 500 vessels as part of that processing system. And these days, those pressure vessel sets are predominantly supplied as some sort of FRP variant due to the fact that it reduces the overall weight of that particular skid or setup quite significantly. It makes the general life of any maintenance team that much better because the weight side of things is significantly reduced. And then the corrosion aspects, as we mentioned, are also completely mitigated to a large degree through the particular choice of material.
No, that's so saving capital and decreasing operating costs, like it kind of showed up there on the screen.
Absolutely.
Well, I have a couple more questions for you, but I did just want to issue a reminder for our audience that if you have questions that you'd like to ask, so that you can learn more about these composite pressure vessels, please comment on them so that Shelby can make sure that they're asked later in the session. Jim, one thing I noticed on the screen when we were showing that video was bond strand. That's a name
Yes.
I feel like I've heard before, but I don't know what it is. So can you tell me a little bit, what is bond strand?
So Bondstrand is an NOV-owned brand, particularly focused at fiberglass piping systems, whether that be rigid bonded systems, flexible piping systems, spoolable flexible piping systems. The Bondstrand name sort of covers all of those as a blanket, and we have multiple facilities all across the globe that do various different manufacturing for the various types of series which we offer at the Bondstrand name.
Okay. So it's like the family under which all of this sits. So when we talk composite pressure vessels, if we say Bondstrand, that kind of, that's one of the many products that we offer under that brand. Perfect.
Yes, that's correct.
So you mentioned global, thinking about and the versatility of these products and the way that they're tailored. It sounds like there might be a lot of design codes or design standards related to composite pressure vessels. What does that look like?
So yes, there are many different standards available out there for the design manufacturing of composite pressure vessels. Predominantly here in the UK, we utilize the ISO group of standards, which for pressure vessels, there are two particular standards which are quite applicable. Obviously, when we look at a greater global scale of things, servicing markets in the US, there's an obvious preference to ASME standards. So in order to try and diversify as far as what we could, we have the capabilities as well as the experience in order to employ either the ISO or the ASME standards and do all of the development in accordance with those. I think the other major benefit we have at this stage is, as of the last couple of years, we have within NOV managed to fully certify excuse me, two facilities, namely the winding plant in Malaysia, as well as our facility here in the UK, to be fully compliant with the production of ASME Section 10 boiler and pressure vessel equipment.
Wow. So no matter what standard you're operating under, in terms of as a customer, you can trust that whatever you're getting from fiberglass systems is going to meet or exceed that requirement.
Absolutely. Yeah, we pride ourselves very highly on making sure that we deliver the safest equipment we possibly can within the guidance, as well as all of the verified processes which come through utilizing those standards. ASME in particular is a really important accolade for us because there are only a handful of other companies in the entirety of the world that hold that accreditation, and I would go as far as being very comfortable to say that that number is sub 20.
Oh, wow.
Globally. And we make up I think the UK facility makes up one of 2 or 3 facilities in the entirety of Europe that are capable of producing to that standard with a fully compliant stamp at the end of the process. And then the sort of major chunk of the remaining manufacturers are based sort of over in the Eastern Hemisphere.
So is that a competitive advantage for you? Are customers really appreciative of that? Or is that just something that makes you all feel more confident with the product you put out to market?
It's a bit of both for us. I think, it gives us a lot of confidence that we are capable of producing to an extremely high standard, but it is also something which we have seen in many inquiries over the years for depending on where assets are to be deployed. There are very often very stringent requirements to adhere to either ASME or ISO standards, and being able to produce very accurately and very consistently to those standards is a big sort of plus point for us.
No, definitely. I feel like you're trusting the experts if you come to Fiberglass Systems for this, to tailor something that meets your needs, but then also, like I said, kind of meets and exceeds what seem to be very stringent standards.
Absolutely. It's not always the easiest thing to get right, but every time we undertake one of these sort of little adventures with regard to a specific requirement from a client, which they haven't necessarily been able to get met through any other manufacturer, our sort of perseverance and enthusiasm has very often helped us push the boundaries on our own manufacturing as well as supply lines. And we have very often managed to get some fantastic product out to clients that were very worried about getting those items due to some of the difficulties they'd experienced at other points in their procurement.
Perfect. Well, now we're going to ask Shelby for some audience questions to see if they had anything else that they wanted to ask you. But I appreciate everything that you've shared so far, and I might jump in with a few of my own.
Oh, please do.
Shelby?
All right. Yes, this first question comes from Owen on LinkedIn. And he actually was asking, I think, was I muted? There we go. So the first question comes from Owen on LinkedIn, and he was asking, can a CPV at a low pressure be rapidly raised to a higher pressure?
Very much so. A lot of our qualification testing is based on destructive testing of prototype items. Our test regime on those is essentially to take that pressure vessel from ambient up to its design pressure within 60 seconds, or its factored design pressure. So we would be pushing it to its absolute limits in 60 seconds. And for the best part, most often we exceed what our expected limits are, and we don't get the sort of typical failures you might think you get with composites. It's not a completely catastrophic failure. It is more it's a substrate failure. So we refer to it as matrix cracking. And essentially what that means is that the binding material, which keeps all the fiber attached to every other bit of fiber, has failed, causing a leak path. And due to that leak path, you get a very, very sudden release of pressure, but you don't get all the sort of flying componentry, which you might imagine in a failure test.
Okay, so excuse my ignorance here. When you're talking about, when Owen's talking about taking something from a low pressure to a high pressure, that's increasing the pressure of the material that's inside the vessel, is what we're talking about? Okay.
Yeah, so we're compressing whatever contained fluid there is at a rapid rate. Most recent sort of example would be a vessel which we had developed, which had a 16 bar operating pressure, but with a six times safety factor on that, we needed to achieve a minimum failure point of 96 bar. Now, accelerating from ambient pressure all the way through to 96 bar within 60 seconds on a vessel with an internal capacity of 500 odd liters means that there isn't a fantastic amount of additional volume pushed into that vessel, but it's the rate at which that pressure changes, which is quite impressive. But it is entirely something which can be done, and we can always design for those additional considerations.
And what drives that pressure change? Is that just
sometimes
normal operations or more?
There are a number of factors involved.
Okay.
Could be things like instantaneous opening of valves, which might not necessarily be something which is particularly allowed in the operation side of things, but it could be an accidental occurrence. that structure still has to be able to deal with all of that capacity sort of hitting its internal volume at any given time, and still, maintain the level of safety which it was designed with at the outset.
Got it. Shelby, do we have anyone else alongside Owen with questions?
We do, absolutely. We actually have a lot of questions, so I'm really excited to get to these. I love seeing our audience when they really have a lot to throw at us. It's always my favorite shows. So this next one actually comes from a comment made by Mahdi on LinkedIn, and he was talking about carbon fiber. And so I was just wondering, carbon fiber, it's a word I know I certainly hear a lot, just in the consumer product market. And so I'm wondering, does carbon fiber play at all into what we're talking when we talk about composites and composite pressure vessels, or is it different from fiberglass? Can you talk a little bit to that?
Yeah, so again, as I mentioned very early on, the reinforcing material in the cases for us as NOV is very often just e-glass, which is just a grade of filament. There are many others, carbon fiber being one of those, aramid. You get hybrid combinations as well, which are a mix of fiberglass as well as aramid, or aramid and carbon. All of those can be utilized, but certain reinforcing materials have characteristics which make them better or worse depending on what the application is. Carbon, for example, has a very low strain to failure rate compared to what some glass substitutes do. So realistically speaking, we utilize glass more often than what we use carbon. Carbon's bending capacity, on the other hand, is fantastic versus something like e-glass. So if we were doing something more aligned to a linear structure, which had to take on an awful lot of bending force, we would probably be sort of looking at something like aramid or carbon instead, if there was enough motivation to use it, because there are some significant price differences in the materials.
Mm-hmm. And so we have this next question. Kui on LinkedIn wanted to ask, how do we ensure a high quality of these CPVs during the manufacturing process?
That's a great question, really. And this is where ASME as an accreditation really holds a bit of weight. All of the manufacturing methods which we use in order to produce a pressure vessel are audited and monitored throughout the production process of any vessel manufacturing project, whether that be for one vessel or 300 vessels. Every single one of those vessels will undergo the same series of inspections and same evaluation criteria from start of process to finish. This is something which isn't necessarily as applicable in some other standards, but ASME have really got a button down when it comes to making sure that those pre-audited processes are continuously carried out in exactly the same fashion from one manufacturing process to the next.
The consistency matters.
Mm-hmm, absolutely.
Absolutely.
Absolutely. And I think we're going to do about 2 more questions. If you do still have any other questions, have no fear. You can go ahead and comment them. We'll still try to go in the comments and answer them after the show, or reach out to you elsewhere. But for today, so a couple more. The next one I wanted to ask is, are CPVs suitable for low temperature service and condition?
Yes, very much so. Composite material almost behaves better at colder temperatures than what it does at warmer temperatures, because it's stiffer. So the brittleness aspect of it will come into play at a certain temperature range. But we've got applications where we have sent composite pressure vessels down to the seafloor at 250 odd meters below the water line, and they function without any problem.
Wow.
The only considerations which we obviously have to put in for applications like that, specifically in the subsea realm, is osmosis, which is essentially water penetration into our matrix or the resin system which we've used in order to manufacture. But that is it's a long-term degradation aspect, which again we designed for and is considered through an awful lot of testing and verification.
Okay, you can tell I'm a neophyte, but the subsea operating metallics, I couldn't use those down there, right? In the situation that you're describing?
You could do. They are just an awful lot more expensive to put at the bottom of the ocean than what
Okay.
the equivalent FRP component would be, because you have to tack on things like cathodic protection. Um, certain operations will quite likely see things like hydrogen embrittlement of certain metals. So the particular specification of metal which is used in any fabrication for an item that has to go subsea is always right at the top end of what you would see for a metal spec, which invariably makes them extremely expensive and that much more difficult to manufacture.
Okay, yes, it really seems like subsea is an environment that you're perfectly tailored for.
Absolutely, it's a market which is becoming very interesting for us and has been developing very, very nicely over the last 5-10 years.
Well, Shelby, I think you said you might have one more for us.
I sure do. And you know, this question came in here at the end, and I think it might be one of my favorites, just because all of my dealings when I've worked with fiberglass systems, kind of a common thread, whether it's pipes, poles, pressure vessels, is that fiberglass or composites, they last longer, less corrosion, and that's a big benefit. But in case of the need for maintenance, we got a question on LinkedIn asking, what is that process like if maintenance is needed on a composite pressure vessel?
So again, maintenance aspects are actually significantly easier with composites than what people might believe. In piping systems, for example, a lot of the materials and equipment you would use could be very much likened to what a woodworker might use. Things like chisels and lathe sets, or just quite rudimentary equipment. It also takes out consideration for things like spark potential, because you don't need to go around with a hot welding machine which is flying sparks all over the place, which obviously on something like an oil rig
Dangerous.
is a big no-no. All of our processes involve a bonding or a laminating sort of event in order to tie two pieces together, or get socket bonds which utilize epoxy-based adhesives. And in order to cure those particular joints up, the only thing we realistically need is a heating blanket which functions at a temperature between 110 and 150 degrees. All of those heating blankets are, generally speaking, can be bought as completely intrinsically safe items with a very, very, very low spark potential. So for the marine and the oil and gas industries, there are a lot of benefits in that area. And again, for maintenance side of things, because of the significant reductions in weight, generally the logistics of moving items out or taking spoolage out of a difficult to work in area is actually not that big an ask, because there's such a massive saving in the weight aspect.
Mm-hmm. And I think that might be the perfect segue. I couldn't have planned any better to answering our Rig Geek question, which was about that weight saving. And so we're gonna show the Rig Geek question one more time. So as I'm reading it, if you think you know it, you still have a couple seconds left here to slide in with some answers. So we asked again, what percentage weight saving can be typically expected when switching from conventional metallic pressure vessels to composite pressure vessels? So we've heard all about them now today. And so the answer, I always feel like I want a drum roll here, but there we go. I hear it from our production team. The answer to that is about at least 30% weight savings when compared to metallic equivalent. So it's quite substantial when you think, I always think the bigger the weight, I mean, the more that 30%, that percentage kind of is realized. So that's really, really great.
Well, I mean, you get so many benefits out of this, of materials tailored to meet your requirements. Then I feel like just the comparison of standard metallics can't quite do it. You've got the weight savings, you have the lower cost, you have the lower maintenance. It's pretty impressive in terms of all the things that composites allow you to do. And the versatility, like the pure versatility of the product line, I think is so impressive.
Yeah, the versatility that comes out of manufacturing with composite materials is very interesting, and it is an industry which is developing hugely at the moment. there are a lot of initiatives happening with the likes of Middle Eastern groups, folks like Saudi Aramco and others who, are massive producers of oil products. And in many cases, they produce some of these substrate materials, which we would utilize in manufacture. And with their assistance and their backing, there are a lot of initiatives going on in the background which are driving the incorporation of FRP materials into the oil manufacturing industries across the globe. And it's a very positive way of utilizing what we get out of a process which already delivers many, many benefits.
Well, Jim, I know with your expertise and enthusiasm, we could continue this conversation for so much longer. But before we close, I just wanted to see, where could people go more to learn, or where could people go to learn more about composite pressure vessels?
So NOV's website have an area for bond strand, and all of our composite pressure vessels are listed either or directed through the NOV website. I'm sure that Shelby may well be able to provide us with an address for that. I don't have it to hand myself, but there is an awful lot of information on there. And if there's something that you see or don't see on the website, and you're interested in finding out whether or not it's something which is feasible or possible, we are always more than happy to have a look at it and give you an assessment, because the likelihood is we can probably find a way to do it.
Well, thanks so much for taking the time to talk with us. It's always nice to speak with someone as passionate as you.
Thank you very much for the time as well. It's been a great experience.
Thanks. And from all of us here at NOV, thank you for watching and for listening, and we'll talk to you next week. Enjoy your day.